All right, in this video, I'm going to be going over scenario 3, which is asking the question, how does a positive acetate strip attract a neutral pith ball? And this is an interesting question because we know that likes repel and that opposites attract, but it's a positive and a negative that attract, not a neutral and a positive. So what happens that allows this to go down, this pith ball to move towards the acetate strip like we've observed? And so let's look at our initial situation. Now, even though these objects are close in the model, let's say initially they're far apart. So I'm going to kind of represent that with that line. And the acetate strip, it has 10 atoms. So I need to have 10 protons because that defines how many atoms there are. The electrons could change. And it has a charge of positive 4, which means that I need to take away 4 electrons. So it has 4 more protons compared to electrons. So 6 electrons, 10 protons. Right? Now, since the acetate is an insulator, it was charged in this upper right-hand spot. And with an insulator, the charge can't move very freely, so it's only going to be positive in that one area right here. If we move over to the pith ball initially, it's neutral, and it has 10 atoms, so 10 protons. And since it's neutral, it's going to have the exact same amount of electrons. Right? So let's talk about what happens when we bring that acetate strip near the pith ball. What we start to see is that pith ball is attracted to the acetate strip. So why is that? Well, we have some other information about electron affinity, that the pith ball has a greater electron affinity compared to the insulator, but this information actually doesn't come into play because that only matters if we're charging 2 insulators with friction, and that's not the case right here. Not only that, but these objects don't even come into contact with one another. Okay. Oh, and by the way, my pith ball is going to be a conductor, and that's going to be important. So now my acetate strip is being brought over towards the pith ball, and what ends up happening is the electrons here are attracted to this positive end of the acetate strip, right? Negative and positives attract. And if this was an insulator, let me grab my insulator piece. If this was an insulator, these electrons would be attracted to this side, but they couldn't move, right? Because electrons can't move well in an insulator, but it's a conductor. So these electrons are attracted to this part of the acetate strip, and they'll start moving over towards this side. They're trying to get as close as they possibly can to this positive side of the acetate strip. So the electrons have literally shifted over. The amount of electrons and protons hasn't changed at all, but the electrons have shifted. And that makes this side negative of the pith ball and this side positive. So all of a sudden, I have this positive end of my acetate strip and my negative part of my pith ball, and well, negative and positives, those things attract. So that explains why my pith ball, right, even though it started off neutral, because the electrons shifted, they attract one another.